Now that we've done some practice problems, we're going to get into some word problems that are more realistic, because you're not just going to be given a math formula and asked to solve it in real life. You're going to be given data, and you're going to have to work your way there. So if you were in the explanation video about how to see what derivatives are and what they really mean, this should be even easier, but I think we can get through it. They tell us the unemployment rate is represented by U of t. I'm just going to call it the unemployment rate. Now, derivatives tell us what to expect from little chunks and steps. So I'm going to graph this out, and it's not going to be accurate, but you'll see how I do it. Let's say we're starting at 4.2, we're going to go down to 4.0, 4.7, 5.8, 6.0, 5.5, 5.1, 4.6, 4.6, 5.8. The graph's going to look something like this. We don't care too much. We want something of a visual. That's pretty close. They want to know, what is u prime of t? What is the derivative of the unemployment rate? Well, the derivative is what creates the original function. In the explainer video, we showed that if you have a displacement, if you're going to travel a certain distance, you can't just magically do that. Distance has to be created by its derivative, velocity. You have to have a speed, and you have to travel that speed for a certain number of ticks in time to get to a certain amount of distance. But even worse, velocity is created by acceleration. You can't just start at 100 miles an hour. You have to speed up to it. So derivatives, like acceleration, create the function of velocity, and velocity, the derivative of distance, creates your displacement here. And we're going to look at the same thing here. So what would create the unemployment rate? That is dependent on what our variable is that we're looking at. In this case, it's time. So this is the change in unemployment rate over some change in time. Delta means change. And usually that means something like y2 minus y1. That's how you find the change, the difference between two things, okay? So what does delta u, delta t mean to us? That's the, can I spell? Am I dyslexic? Change in unemployment per change in time. What does that mean? It means that every change in time, 1 year, gives us a change. This here would be a negative 0.2. The next one would be a positive 0.7. This one is an increase in 1.1. This one increases in 1.2, and so forth. So this is what the derivative represents here. And you got to kind of look past the symbology and understand the actual meaning. Actual meaning. Do I have the other program or the other one set up? No, I have the same one set up. Let's do another word problem. I know I have it ready for us here. Let's pull it right out of this. Bam. Okay, we'll bring it over here. You know what? Let me clear this whole thing out real fast. We'll fill it in, and we'll do it together. Let P of t be the percentage of Americans under the age of 18 at time t. This table gives us values from that function. Okay, no problemo. So we see it's going to be 10 years difference per, right? Not 1 like the last time. So P of t, they tell us, is the percentage of means multiply, Americans under 18. So we'll just call it 18 minus or something up here. So what do you think P prime of t would be? That would be the change in percentages of Americans under 18 over the change in time, right? So that would be the change in the percentage of Americans under 18 per 10 years. This is already full credit as far as I'm concerned. But when you're looking at this, it wants examples here. So what are its units? Okay, let's look at the units here. The percentage change of Americans under 18. So that's just a number like 5 or something like that. In fact, we can do an example part. Let's look at the first from 1950 to 1960. It would be 31.1 minus 35.7. And that's equal to what? Is that negative 4.6 or negative 4.8? I never do that math correctly, but I think it's negative 4.6 per 10 years. So this is going to be our answer. And there's no unit up top here as far as I can tell, is it? Because percentage isn't a unit, right? I guess we can call it percent. That means that over the course of 10 years, which is our one time step here, the percentage of Americans under 18 has gone down by 4.6. That's all that means. That's all it means. So now my question to you is, how would I make this more accurate? Well, you can't really change the accuracy of a percentage, but you can reduce the time window that you're looking at. So if we had data from 1951, 52, 53, this unit would be per 1 year. And that would be much more of an accurate depiction over time, because our entire graph from 1950 to 2000 is only like 5 data points here. But what if it was actually like this? You know, you don't know. Until we have better data, we don't know. Well, that one probably wouldn't be right, but you get my point. And this is how we look at the word problems. Try and go from your formula to being able to tell yourself what it means. And what this proves for us, by the way, if you want to work it backward, is that if you look at per 10 years, that means every 10 years, we have a number that shows us what created our original function. So if we look at per 10 years, we'll know that this negative 4.6, if we were going backwards, as it actually increased, this should have been a positive 4.6. And maybe I should have done it this way, but the effect is the same, because we're not really worried about the number. They asked, what is the meaning and what are its units? Make sure you understand this well enough to move forward into harder questions later, or come back and try more of these until you do.